The problem here with me is under Higgs apparatus. Let me quickly go through the question. In an experiment to determine the density of a liquid using Higgs apparatus, the height of the water column is 12.0 centimeter and that of the liquid column is 16.0 centimeter. If the density of the water is 1.0 gram per cm cube, calculate the density of the liquid. So in this particular problem, what we are looking for is the density of what? Liquid, okay? The first thing you need to do is to bring out the what? The parameters from the question. So let's quickly do that. Solution. Okay, in an experiment to determine the density of a liquid using Higgs apparatus, the height of water column is 12.0 centimeter. That means height of water is equals to 12.0 cm. Okay, let's continue. And that of the liquid column is 16.0 cm. That means height of the liquid is also given. Height of liquid is equals to 16.0 cm. Okay, let's proceed. If the density of water is 1.0 gram per cm cube, that means the density of water is given to us. Density of water, let me use that as density of water. Density of water is equals to 1.0 gram per what? Per cm cube. That is, let me use this one, raised to the power of -3. Okay, that's gram per cm cube. That's my density of what? Water. They now said calculate the density of the liquid. That means my density of liquid is unknown. Density of liquid is unknown. That's exactly what we are looking at. Okay, so the next thing I need to do is looking at my parameters. I'll now have to know the kind of formula I'm going to apply. So let me apply with what I have. Higgs apparatus has a formula. So let me quickly write the formula for Higgs apparatus. So I have my Q, density of water times, okay, time, let me space it, times my height of water times gravity is equals to my density of liquid times height of liquid times my gravity. Okay, if you look at this particular formula very well from Higgs apparatus, you discover that we have gravity. I know that gravity is constant, which is 9.8. You understand? 9.8 meter per watt second square. So I'm going to cancel, gravity will cancel what? Gravity, okay, because it's constant. Okay, let's proceed. So in doing that, I'll now have my density of water times my height of water is equals to my density of liquid times my height of liquid, because gravity cancel what? Gravity. So with this, what am I even looking for? I'm looking for my density of what? Liquid, okay? So the first, what I'm going to do right now is to make my density of liquid my subject of the what? Formula. So I'll divide both sides by coefficient of density of liquid. So in doing that, I'll have this, my density of liquid is equals to is equals to my density of water times my height of water divide by my height of what? Liquid. Okay? Because I am looking for what? Density of what? Liquid. So the next thing I need to do, I'll need to substitute all my values into my what? My parameters. Okay? So let's proceed. I'll have my density of what? Liquid is equals to, anyway, I see my density of water. My density of water is 1.0 times my height of water is what? My height of water is 12.0 divide, okay, divide by my height of liquid is what? 16.0. That's 16.0. Okay, so let's proceed. My density of liquid is equals to, look at how I'm taking my time bringing it out. You understand? Bringing it out so that it will be very crystal clear. Okay, so 1.0 times 12, I'll still have my 12.0 divide by what? 16.0. Okay, so my density of liquid is equals to 12.0 divided by 16.0. What will I have? I'll have my 0.75. Yes, 0.75 gram per cm cube. That's gram per cm cube. Let me use this as raised to the power of minus 3. Okay, so that is all about the question.